So we've talked a little bit about getting a better definition of continuity so we can actually do some problems. I want to just quickly review the definition that we talked about. So let's write it down again. It doesn't hurt to repeat ourselves. How about I abbreviate continuous to CONT apostrophe S? So f is continuous at x equals a if, let's use that useful definition that we had. I'll write it, I hope I didn't confuse you with it, I'll say it again. Well, f of a is defined. And I'll write it like this. The limit as x goes to a from the right of f of x, and the limit as x goes to a from the left of f of x, both exist as finite numbers. And all three of these finite numbers should be equal. So f of a is the same as the right limit, and that's also the same as the left limit. I'm writing it a little bit different than I did on the last video, but it's really the same thing, okay? All we need to check is that the number a is in the domain, so f of a is defined. The left and right limits, they usually always exist unless the function is extremely weird. And as long as they exist as finite numbers, the second condition is also satisfied. And this third condition is the main one, okay? The value of the function has to be the same as the right limit, and it has to be the same as the left limit. That's really the crux of the definition, okay? And remember, all of that is the same as that original, quick, very concise definition of this, right? This is a very nice, quick way of saying all of this. But it's not this nice definition here that's so compact. It doesn't really it's not that useful for actually solving problems. And that's the whole reason why I give this alternate definition right here, to make our life easier when we come to solve a problem. So let's try this one. Example. So let's define a function f of x to be a piecewise function. Let's say cx squared plus 2x. That's when x is less than 2. And x cubed minus cx. That's for x greater than or equal to 2. Now, the first thing I want you to know is that notice this top function is a polynomial, and this bottom one is a polynomial. And we know polynomials are continuous everywhere. So it's kind of like we have this square polynomial quadratic, right? And then we have this cubic. Something like that, maybe. And our number 2, excuse me, I'll write it a little bit straighter. The number 2 is like somewhere here, right? And the question is how do we make these match up? I guess, by the way, the open dot would be on this one, and the solid dot would be there. Because to the right of 2, we have that equal sign, right? So that's why the solid dot goes here. Now, I think which value of c is going to make these graphs line up nicely. In other words, let's say instead of having it like this, let me, excuse me just one sec. Sorry, gotta get out of this. All right. I just wanted to show you this. You know, for the right value of c, this cubic and the quadratic are going to match up perfectly. Okay? And that's our goal. For all the other values of c, there's going to be a gap in it, right? Like this. But for that one value of c, or maybe, I don't know, maybe there's more than one, they're going to be the same. I think there's probably only one. We'll see. All right, so we kind of have a feeling for what this question asks. I should actually write it down, though. Here's the question. For what value of c is f continuous at x equals 2? That's our goal. So we're going to go through these. Notice that f of 2 is defined. That's no problem. The left and right limits are definitely defined as finite numbers because we're just dealing with polynomials here. To do these limits, we're just going to put the numbers 2 inside each of these. So again, really the main condition is that third one, right? So why don't I scroll up like this, and let's focus in on this third condition. Why don't we first find out... Whoops. I made a little mistake here. This should actually be 2, right? We want to know what value of c is f continuous at x equals 2. And this picture here, I just made that up, didn't I? So I don't know really how the graph looks, so I'm going to just erase that. But it gave us an idea of kind of the essence of the problem. So let us first do f of a. This is the way I like to do it. I first do f of a, then I do, say, the right limit, and then the left limit. And then I say to myself, I need all of those three values to be the same. And that's what's going to tell me what c is, okay? So let's start off with f of a. Well, a is 2 here, right? So what is f of 2? Notice that when x is greater than or equal to 2, I use this one, right? So it's 2 cubed minus c times 2, which is the same thing as 8 minus 2c. All right. Now let's do the right-hand limit. So the right-hand limit at 2, what is that? Well, since x is going to 2 from the right, that means x is a little bit bigger than 2. And whenever x is bigger than 2 or equal, we use this second formula, right? So what I'm going to do is I'm going to replace the formula. I'm going to replace f of x by the formula that it really is for numbers x that are bigger than 2. And this is a limit of a polynomial, so I'm allowed to do the limit just by putting the number in. No big deal. That's the same as this one, isn't it? But the more interesting one comes next. Let's do the left-hand limit now. When I do the left-hand limit, x is going to be a number that's a little bit smaller than 2. And whenever x is smaller than 2, I should use this first quadratic formula, this quadratic polynomial here, to replace f of x by. So let's get rid of f of x and replace it by cx squared plus 2x. And again, this is a polynomial, so to do the limit, I just put the number in, right? 4c plus 4, right? Okay, now let's look at these quantities. Criteria 3 says all of these have to be the same. Well, 8 minus 2c and 8 minus 2c are definitely always going to be the same. This is the interesting right here. These must be equal, right? That's what it's kind of saying right there. So we're going to set those equal to each other. We'll get a very simple little algebra equation, and we'll obtain the answer in a few steps. So for those to be equal, we need 8 minus 2c to be the same as 4c plus 4. Why don't I bring the minus 2c to the right-hand side, and I'll bring the 4 to this. So 8 minus 4 equals 4c plus 2c. So 4 is equal to 6c. So c is 4 over 6. And if I simplify that, I get 2 over 3. All right, so the value of c being 2 over 3, that's going to make those two graphs meet up nicely. And I'll just write a little quick sentence here to conclude the problem. It's always good style to do that. To make f continuous at x equals 2, we need c to be equal to 2/3. Something like that, okay? So that's a very common kind of continuity problem to do. I hope that makes sense.